Good morning. Welcome you all to our radiation oncology physics course, and today we are going to deliver the topic measurement of ionizing radiation, as this is a very important and very crucial chapter of crucial topic of radiation oncology physics. We have divided the measurement of ionizing radiation in 3 lectures, and today is first lecture of this measurement of ionizing radiation topic, and in the whole lecture series this is actually 8th lecture. Now, learning objective of this class is, first we will discuss the principle of measurements, how and why these measurements of the radiological quantities we have mentioned, discussed in last class, in the radiological quantity and units. We will discuss various types of radiation detectors. We will discuss the composition of measurement system, and we will discuss the gas filled type of detectors in very detail. Now, what is the need of measurement of radiation? Because we treat the cancer patients by delivering very accurate quantized dose, so we need to measure or calibrate our equipment by using radiation detectors or radiation measuring system. We need to quantify the radiation level around the radiation installations. The radiation installation means it may be the X-ray machine in radio diagnosis, it may be CT scan, it may be therapeutic machines like linear accelerators, cobalt 60 therapeutic machines, or any type of radiation installation such as radiation reactors. So, we need to quantify the radiation level around this radiation installation to protect the public and to protect the radiation worker. So, there is need of measurement of radiation for protection purpose. Sometimes because of some mishappening, the radiation accident happens, and to manage this type of radiation accident emergencies, we need to measure the radiation level. So, there is a need of guidance of radiation accident and to manage the emergency of radiation accident. Again, we need to measure the radiation to quantify the dose received by individual because of radiation accident for the management or for treatment or for rehabilitation of the exposed personnel. Now, the problem in measurement of radiation, we can measure any quantity or any quantity in our daily life by using our senses. We have 5 sensory systems, sensory organ, and such as sight, smell, hearing, taste and touch. But problem with radiation measurement is we can't see the radiation, we can't smell the radiation, we can't hear the radiation, we can taste the radiation, or we can touch the radiation. So, our radiation, our sensory organs failed to measure or to detect the radiation of any kind. So, how we measure the radiation? The radiation causes various type of effect, and if these effects are detectable, we can measure the radiation by using the indirect measurement system, and this is actually indirect measurement system because this is not, we are not directly measure the radiation, we measure the radiation effect, detectable effect while traversing any material medium, and we can measure the radiation. Now, first we know in our earlier classes, in the last classes, we have discussed about various kind of ionization process. We know that while traveling through material mediums, the radiation ionize the atoms of the material mediums, and if we able to detect or able to measure the ionization, we can indirectly measure the radiation amount by which this material medium is exposed. So, first one is ionization effect. Now, second one is chemical effect. Some chemical solutions and some combination of mixture, so combination of solution may show some chemical effects after exposing of radiation. So, if this chemical effect is detectable or measurable, we can indirectly measure the radiation by using this chemical effect. Now, again some solid state device shows some effect after exposure of radiation, and this solid state effect can be measured by electronically by various methods, and we can measure the radiation in indirect way by measure the amount of detectable solid state effects. And next is, as radiation is a energy, is a type of energy, so this energy is absorbed by material medium. While absorbing the material medium may get this energy, may convert it into heat energy. Now, we know that if some material mediums is absorbed some heat or received some heat, the temperature increases. In radiation conversion, there is a very minimal amount of heat is produced, and this heat produced very negligible amount of increment of the temperature of the material mediums. Now, if we have such accurate type of thermometer, we can measure the increment of temperature, and indirectly we measure the ionizing radiation, and this is the heat effect. And last is biological effect. If any biological system or any human being is exposed by any unknown radiation, it shows some biological effect such as chromosomal aberrations, and these chromosomal aberrations are detectable in microscope. Now, if we count the amount of chromosomal aberrations or any other kind of biological effects, we can indirectly measure the amount of radiation of exposure. So, we have ionization effect, we have chemical effect, we have solid state effect, we have heat effect, and we have biological effects. And according to these effects, there are various kinds of detectors developed to measure or to identify, to detect the ionizing radiations. We use almost all kinds of detectors in radiation oncology and for our daily purpose, and the purpose of energy, the radiation measurement is different for different types of radiations, for different types of purpose, and for different level of accuracy. We use various kinds of radiation detectors. Now, what will be the ideal detector characteristics for measurement of ionizing radiations? Now, ideal is a very ideal term which to define for anything, for ideal human being, for ideal any education institute, for everything. But here these are the characters I am going to discuss about the characteristics of ideal detector. And first characteristics, the ideal detector should be compact and should be strong. It should be compact in size and it should be strong. Again, the next is it should be efficiently detect the radiation. So it should be efficient in radiation detection. And my next point is it should respond very fast. After exposing the radiation, it should show the radiation effect and we can measure the radiation instantly. It should be stable in terms of time and environment, and it should be low cost. The cost should not be very high, and it should be convenient of use. The use of this radiation should be the radiation detector should be very user friendly, and there should be no radiation damage happened with this radiation detector after exposure of ionizing radiations. And the most important character is the response of this detector should be independent of energy and should be independent of exposure rate. But here is a statement that there is no ideal or universal radiation detector. As I have already mentioned that in radiation oncology we are using a range of detectors which are different in their principle of energy detection, radiation detection, and they used for different purpose. So we need to understand there is a series of radiation detectors which are used in radiation oncology physics. Now, what is the composition of radiation measurement system? In radiation measurement systems, there are 4 main composition for all type of detecting system or for all type of radiation measurement systems. First part is a detector. Now, detector contains a material medium, and this material medium absorbs the radiation energy, and this radiation energy converted the absorbed energy into the signal. So detector contains material medium, absorb radiation energy and converts the absorbed energy into the signal. Next part is the radiation energy effects may be very small, so we need to amplify this signal electronically. So there is a need of amplifier to amplify the original signal received from the detectors. So we need a amplifier which electronically amplify the minute amount of signal. Now next part is processor, where the amplified signal is processed and translate this amplified signal in radiological units. So third component is a processor. Now next and final component of the radiation measurement system is display, where this display is presented to the meter reading in format of analog, or it may be the analog signal, or it may be in the digital format. Now this is very important portion of this lecture, that is gas field detectors. We will discuss about gas field detectors very elaborately, because this is the basis of devising various kinds of detectors, ionization detectors, or proportional counters, or Geiger-Müller counters, or various kinds of radiation detectors are devised according to this as per this gas field detector principles. So here is a common detector assembly we have shown in this schematic diagram, where detector, this is the detector, and this detector is filled with a gas, or it may be air. This is actually cylindrical in shape, and we have 2 electrodes. One is outer sheath, this is act as electrode, and another is central wire, this is also another electrode. The central wire is anode, that means positively polarized, and outer sheath is cathode, that its polarity is negative. Now if we apply a voltage here, so after exposing from the ionizing radiation, there will be ionization, means the gas atoms will ionized in ion pair. So, radiation produce ionization plus or minus ion pair, and after applying the voltage, these ions drift towards electrode. Accordingly, means positive ions goes to the cathode and negative ion goes to the anode, and we will get an ionization current because of this drift, and this can be measured by a outer circuit, that is actually a ammeter, and this ionization current is proportional to the number of ionizations. Means now we are able to detect manage we are able to measure the radiation, ionizing radiation, in terms of ionization, amount of ionization. So, depending on the strength, this voltage is variable, and depending on the strength of the electric field, various type of radiation detectors were devised, and these radiation detectors were used for different purpose, for their level of accuracy is different, and these are series of detectors devised by increasing this strength of this applying voltage. Now, what will happen from region to region, from voltage applied voltage region to another applied increment of voltage, what will happen, we will see. Now, this is the pulse size. Here is a graph. This is shows, this is the current axis, means ionization current axis, and this is the applied voltage, means this axis shows the pulse, and this axis shows the applied voltage. Now, first part is region of recombination. In very low voltage, we start with 0 voltage, then we increase very slowly. In very low voltage, what will happen? The ion pair do not receive enough acceleration, and they are unable to reach the electrodes, means they are not getting the sufficient acceleration from the potential. So, they may recombine together, plus or minus may combine together. So, instead of being collected by electrodes, they are combining each other. So, we will not get sufficient pulse or sufficient amount of signal to process. So, this region we do not devise any kind of detector. So, this is the part A, where it is the region of recombination, and this is the very low voltage region. And one more thing, here this cyan color is alpha curve for alpha particle, and red one for beta particle, and green one for gamma radiation. Now, next region is region of saturation. This is the region of saturation, means where the voltage gradually increased after this region of recombination, and if we increase the voltage, the primary ion pair formed by initial radiation are collected by the electrodes, and individual events cannot be detected, but we get a current which is measured remains same over the range of applied voltage. This is, you can see, there is not much changes from changes of voltage. So, this region is known as region of saturation. So, this voltage region is in order of 50 to 300 volt, and most important radiation detectors and useful radiation detectors for our field, radiation oncology physics, we devise the ionization chamber. This is used for dose calibrator, and it is operated in this region. So, in this region we have devised ionization chamber. Just remember this one, ionization chamber. We will discuss very elaborately ionization chamber in our next class. Now, the third portion or third region is proportional region. This is the proportional region. Here, when applied voltage is further increased, the ion gains such velocity and energies such that they cause the secondary ionization. Means they one ion is produced another ionization, and this is known as secondary ionization, and this ionization increase the measured current. So this is not primary event, these are secondary event which caused because of high velocity and high energies which they are getting from the acceleration of the higher applied voltage, and this is known as gas amplifications. Now what the total ionization current we received in our meter, that is number of primary ionization multiplied by the gas amplification factor, and the current increases with the increase of applied voltage. In this region you can see the current is increases with the applied voltage, all for all the particles alpha, beta and gamma. So this is proportional to the initial number of ion pairs, and for this part reason we define this region as proportional region, and in this region of voltage region we devise the proportional counter. This is a very important equipment. We have radiation detectors or a radiation measuring system we devised, which count the individual count, because we get a sufficient high level of pulse signal, and this is also used to discriminate radiations from different energies. Means we can separate one energy to another by using this proportional counter. Now next region is region of limited proportionality. This is the D region, where the applied voltage is increased further from the region of proportionality, and the current tends to become identical, and this region is not practically used, and we do not devise any kind of radiation detectors for this region. Now this is the E region, and this is known as Geiger region. Now what happened? It with additional increase of voltage, the current become identical for all radiation. Means this current actually produced by an cascading effect, or you can see avalanche interactions. The avalanche is a very common natural disaster that happens in high altitude region like Himalayas and all. So if we create one event, that will create multiple events, and it will a disaster. So in this region also, if one ionization event is happened, it will cascaded, and it is increased so much that we get a current signal, and this is same for all type of radiations, and this current is produced by the avalanche interactions, and in this part we use the we devise the Geiger-Müller counters, that is known as commonly known as GM counter, and this is used to detect very low level of radiation field. So what is the use of the Geiger-Müller counter? We use this Geiger-Müller counter to survey an area for to detect any kind of radioactivity. Means when we encounter with situation such that there may be a loss of radioactive source, so we use this Geiger-Müller counter which able to detect very low level of radiation, and this is used as a survey meter to survey the area of any type of region. And next part is of this pulse size versus applied voltage. This is the continuous discharge region. If we increase the applied voltage beyond the Geiger region, a single ionizing event which repeatedly discharge and which cause a spontaneous discharge. Even gas of this detector may be ionized in the absence of radiation field. If there is any kind of ionization, it will damage or it will discharge spontaneously, and this region the detector may be damaged, and this region there no detector is available for or devised for this region. So, in this class we have learned about the why we need to measure the radiation, and what is the principle of measuring the radiations, and we have also discussed in detail about the gas field detectors, and we learned that the ionization chamber which is devised in a region of proportionality, and we know that region of saturation, and we devise the proportional counter for in the region of proportionality, and we have devised the Geiger-Müller counter in the Geiger region, which is used for survey of any type of any possibilities to detect the any possibilities of radioisotopes or radioactivity or in any area. That Geiger-Müller counter is able to detect very low level of radiations. And last one is continuous discharge region. Some regions are not useful to devise the radiation detector. One is first one is A, that is recombination region, and D is region of limited proportionality, and F, this is region of continuous discharge. So, these three part we did not devise any kind of radiation detector. We devised ionization chamber for in B region, we devised proportional counter in C region, and we devised Geiger-Müller counter in E region, that is Geiger-Müller region. And that's all for today class. Thank you all.